It's starting. Hello everyone. Hello Andy. You are still hidden behind the fondue cam. Hello Henrik. Hello Sniff. I was like ready 10 minutes ago. Can you imagine? Somehow every camera worked today right away. Hello Chaos. Hello Anthony. Matthias. Hello. Cool. I also changed the bit rate. So YouTube was complaining that I'm streaming at 25 kilobits per second. I changed it to 10 kilobits per second. Hello Johnny. So all the people are here. I moved the fondue cam so everyone is visible. Just for a moment at least. I'm prepared but I'm not prepared. So we did last time, it's a short recap, we did some impedance matching for the 6 times VGA board, ESP32 VGA board. Actually it's this one over here, so there are still some wires dangling around. I simply cut the ends off so we don't get any shorts. And we soldered some additional resistors to 200 ohms resistors so we won't overdrive the ADC of the projectors that are behind me. So we have like 6 projectors all over the place. And that worked fine. But somehow, yeah, I need a new soldering iron. I have a little bit of problems with my current one. So I didn't solder all the other channels. We have to work with the green effect on some of the channels probably today. But I'm not sure that we are using all 6 channels today, maybe for testing purposes at the end. But we have only like, I don't know, I will aim the projectors. We can do a setup. We can aim them. So this is like, I don't have a fisheye camera, but we can project like to the ceiling and to the walls, so you can see what's actually happening, and I can see it as well. So how am I feeling? I'm feeling good today. I was a little bit lazy. It's a Saturday at least. So yesterday I did some gardening, and now we are back to streaming again. So Envy was streaming. Sweet setup. Yeah. Oh yeah. Back to the face. It's like I need to connect my ping pong LED walls again, and I want to mount the wall version 3 on the ceiling here, but then I thought of some kind of brackets that I want to weld and mount them on the ceiling and such, and I didn't do it yet. Yeah. We don't have the microscope connected today, but we have the capture card on the tablet again. So these are a few notes that we made for our testing. So the projectors will be, yeah, we have in the center, we have, okay, the point isn't visible probably. And we have the projectors here, and we want to like project to all the walls and some wireframes, and we want to project some demos. Starfield, I thought the Starfield thing is a good starting point here. Oops. Let's start with the, my pen, start with the Starfield first. And then we can continue with other fondue boiling. And a spectrometer, so audio spectrum display. What I thought maybe we can try today as well is to do, let me get a little bit here. Whoops. We can close this. We can maybe transfer line segments over UDP. So UDP and dots and lines maybe. Dots and lines. So we can maybe send packets showing use the ESP32 just for the purpose of generating the buffers and rendering the lines and doing actual work on the PC. So we can even synchronize it with stuff, or even use Blender or something. I don't know if Blender has like the Python included, and I think we can maybe use some Blender particle simulation and send line segments to the output here. Okay, now let's check what the chat has to say about it. Where's my chat window? Here. Hello, roter Fruchtzwerg. They say hello to Christian. Hello, Christian. Okay. And yeah, fondue is not heat up. It's the rest that we have left over from Thursday, and I made some new croutons with extra butter. I have to go shop groceries later. Johnny, later, just do it now. If you want to shop groceries, just do it now. We will probably need a little bit of time to, and don't procrastinate. We need some time to set up like the basics. So we actually, programming computer graphics is always like that. That's the 90% of like the time in the beginning you see black, and then all of the sudden everything comes together and we see it's actual 3D stuff or whatever we want. So it will be really, really exciting later. Yeah, maybe. It's a coding session, That's the lowest retention ever. I don't expect anything. That's why I didn't announce the stream at all. I have even like this was fog machine there with this remote here. I bought this specific thing just for the video where I was showing the lenticular stuff. So just for this purpose I bought this thing, and we can maybe use it to see some projected lines in the room, like laser stuff later. So at least even with random stuff we get something exciting to see. Envy was live coding Ethernet stuff while live commenting in German. That was exciting. Okay. That's Bond villain remote. It even has some protection. So here. It's like it's like a phone, mini-me phone. Hello? Yeah. 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 Execute. Sharks and lasers. Yeah, there's the sharks button, the laser button, the what's the pit where each seat has like maybe a code here. Yeah, Charles shows a handful of lines with C code. Don't expect much. It will probably end up being everything being green. So we need maybe to... Hello Aaron, hello Oflus, Selim, TC. She's a little bit dried out. Use the VGA outputs in a matrix for extra large projections. Oh yeah, that's working already. That's like the common setup. So we were able to drive 400 by 300 no, 1 bit. We have 6 displays by 640 by 400. So we got like 2000 pixels by 800 pixels. 2K by 800 is the current basic, like the common configuration of the array of 6 projectors. Okay, there is a request if I can say something in German. Natürlich kann ich etwas auf Deutsch sagen. Wir können einen kurzen Ausschnitt hier in dem Stream Deutsch kommentieren. Also ich hoffe, dass mein Fondue nicht zu sehr eingetrocknet ist gestern und heute im Kühlschrank, aber es sieht gut aus. Hab frische Croutons gemacht mit viel Butter. That was German. Okay, I think we can start. You had enough German for one day. Yeah, let's set up the projectors maybe first, or maybe turn it on, not take it apart. No, what? You didn't understand anything. Okay. Switch to the other camera here. Okay, that's like I'm like really tiny. So these are the last trousers that are clean so I'm in summer mode already, even though it's still cold in Germany. But I didn't do the laundry because I wanted to hang everything in the garden for drying, but the weather is really sucky right now. Okay, everything is like here, too many cables. I will just disconnect everything first. I hope you can still hear me because the microphone is quite far away. It's like there. And I also, I turned off like my lights here. I will later also turn off this thing so we can see something. I think that there's not much configuration here. I will put the power on here. Okay. Oh, that's a mess. Oops. Let's not break anything here yet. Okay. Oh, well, that's not covering the whole... Oh yeah, that's much better. Yeah, we need more distance. I will pull the table to the center of the room. Oh yeah, that's not like super. We need more distance here. That doesn't cover anything. Yeah, that's about my plan here. Okay, let's keep it like this part. And turn off the lights right now. I don't like it. We need like a huge distance. Or another lens in front of it. Or we do like two on top of each other and do the array configuration already. So we have like six projections like here. Okay, we can do that. We are not bound to any limits here. But I wanted also to project on the ceiling. Hello, Peter. Okay, VGA 0. And I will be adding the shower curtain again, just for the demo. Ten of 10 projection screen. Okay, let's fill the first projection because we don't see anything here. This isn't the right one. I have the sketch over here. Oh, why? This is like 600. Oh, what mode do we have? 400, this is 800 and okay. It's compiling. Okay, yeah, that's a solid projection. I will add the feed. Yeah, where's the photo of this one here? I can move it. You know what? We can even move the table further away, so we have a bigger projection. We want all the size here. If it's working, I'm not sure if we have enough cables here. Okay. Yeah, that will be okay. Okay, focus. Second screen. Oh no. This one has like this one doesn't like to screw in. I will leave it for the ceiling. Where did all the thingies go? Let's take that one. We just need to cover everything here. I have the impression that 6 projectors might not be enough. Oh, yeah, that's the green effect. Oh no, we might need to fix that. Shoot. Okay, what's the other? What are the other ports saying? Ah, that the other are better than this. Okay. So that apparently that one was very sensitive to the overdriven signal. One channel. Let's continue with maybe the ceiling. If that works, I don't know if we have enough things to set it up. Okay. Or let's start here. That's not working, it's overlapping too much. Oops. Oh wow. This looks shitty from this perspective, but like, it's covering quite some part already. Okay, I will. That's 4 projectors. Let's change the code. I think this is this solid color? No, it's not. Okay, now I have time to read the chat. You can hear it? Okay. Let's read the chat. Hello, Aaron. Fan noise is quite loud, isn't it? I hope you can hear me. Not sure if maybe we should do a hacking session. Can I add my face here somehow? Let's add my face. Boop. Face to the chat. Here. Maybe we should do one hacking session where we open up one of the projector and convert it to passive cooling by adding like a huge CPU fan or something, or at least like super silent cooling. Okay, I will test now since this was. We can maybe add another one. The one that we skipped. I'm missing one foot here. One of the small foots. Okay, we have 5 projectors connected now. Okay. It ain't laser projectors, so it won't be like super cool quality. Oh, maybe we can do it like that. Okay, the 6th one will be up here, but I think I will change the order since we are drawing from the top to the bottom, so we can keep the configuration and continue in a huge screen configuration here. So this is 0 and 3. We swap these two. Zero and 3. And we have the second. This one. No. Yeah. This one and. Oh, wait. Uh-oh. The board didn't like it. Okay. This is already kind of sketchy. Oops. Uh-oh. Okay, the current state doesn't look very, very great. How's you should add OTA ASAP. Yeah, then I need to configure the Wi-Fi first. And then I can imagine that when we like super overdrive the ESP with tasks, that it might cause some problems. Okay, let's try the fondue. Fondue is great. Has he ever said why he's doing this? The answer is easy. It's madness. It's pure madness. I'm doing this because I can. That's the name of the board. It says VGA madness. If it focuses. Yeah. So the silk screen says it all. It's basically madness. Okay, let's do some code. But this loud noise of the projectors is driving me crazy already. This is the Arduino IDE. Let's capture the screen. Oh, I didn't change the resolution of my screen. Uh-oh. Yeah, you're only seeing like a small portion. That's okay. I will zoom in just for you. Okay, so this is hey electronics. Johnny, what did you miss? We have configured 5 screens at a time, and somehow the USB, probably because I used some kind of extensions here, already is complaining, so the ESP might crash. But we want to draw a Starfield. How do we draw a Starfield? We need some stars. Let's start with some clean. Here's a dot. Here's a line. Let's keep this so I know how a line is drawn. I forgot everything about my code. This is basically the code for drawing, filling all the displays. Font, we don't need that. Serial is also not needed. This is the dither function. Okay, let's basically start with some stars. So const int star count, and let's make a fixed star count of how many? 1000 stars, and then we have an array. So int stars let's make it star count and 3 parameters. We have, okay, let's do 3 is okay for now. Now we need to initialize the stars. And void. And basically for int I star count I plus plus, and then now we need to reset stars I 0. Now we need some coordinates, star coordinates. Let's make it random. We had the random function somewhere. Random. Okay, let's simply draw dots, random dots on this whole display. So we have like, let's calculate the size of our screen, or const xres, and the const only means that this parameter won't change, so you can't change this variable. This is only for the compiler, so he is able to optimize the code to be faster at the end. The resolution is 640 times 3. There's also a const, and this is 400 times 2. Since this is our configuration, which is defined here, 3 displays by 2 displays. Xres, and now we simply, the init is xres. I think the random function of Arduino includes the last, so whoops, we do -1, and the y will be, oops, and the last parameter is 0 for now. Okay, so we initialize the coordinates of the stars with random coordinates that are spread all over our projectors right now. I need to get the a standard bitluni setup. Oh, I'm hungry. I need some fuel. One croton per line of code. Okay, this is the setup. We don't want to do anything in the setup except for init stars. So init stars. Oh. Let's simply draw the stars. Draw stars. And this is a function that we still need to implement. And that's basically the same here. Okay, our video display. Let's call it GFX. I will rename it because otherwise we have plenty of okay, wow, this is like some code. Now we only draw GFX and we take dot. Dot is with clipping, so it will clip at screen borders, and we have a dot fast, but I'm not sure how well implemented this is. Dot fast is without clipping. So if we need more speed, we can use dot fast. Okay, and now we can use basically our parameters here to draw it in RGB, and RGB color is basically we have only one color, on and off, and that's GFX dot RGB 255. Oops. I think this will be optimized away anyways, but that's the color. Okay. Does it compile? Oh yeah. Doesn't. Wait, what? You need stars. Oh yeah, draw stars. Yeah, I'm actually using Arduino. We can switch. Okay, something's happening. Yeah. There might be an issue with one of the pins. Oh, do I? Did I overwrite it? Copy paste error. Yeah, here. Okay, but I need to disconnect the last, this one here. I think I need to disconnect this one. And let's see if we can. Is it updating? Some of the VGA ports are preventing it from restarting, I think at least. We can see what the serial monitor says. Okay, that's a boot loop. Yeah, okay, we got a boot loop. There is somewhere an error. What's going on? Yeah. What? Oh. We might be out of memory. We don't even have 1 kilobyte left. No, it's like 8 kilobytes. Oh. Is Max exclusive? Are you sure? Yeah. Okay. So we need to lower the resolution a little bit. Or you can see the stars, can you? The compression is completely, so we can see some stars. I will make it, can you see it here? In the center. Like here are some stars. Star, 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 star. Yeah, no. In this resolution, we, we actually don't have enough memory to run it in full resolution. Okay, so let's reduce it a little bit. Let's do we have 350? Okay. Very random value. Okay, we have a 350 resolution available. Okay, so we will get some RAM free for that. But I think this is something you need to like think of if you're working with such a device, that you can quickly, if you're running it already at its limits, that you quickly run out of memory. Okay, now we have a Starfield. I will focus the projectors a little bit more. You can't see anything, can you? Shoot. Okay. This. Oh no. This. Oh, we have even some actual hardware keystoning here. Okay, this one is completely out of focus. Wait a second, I will make it so you can probably see it better right now, but I can do a rendering. Okay, let's make it so we have twice as huge pixels, 300 by 200, and also 320 by 200. So you will be able to see the pixels. And we have plenty of memory then left. Yeah. Stars bigger. We don't need a high resolution if you can see the individual pixels on stream. So here is a small. Okay. Phase 1. Now I don't know how my library works. So we need some... At least I'm able to cover the whole room in pixels, or at least half the room in some random stars. Bitluni's planetarium, yes. We draw them bigger. Let's make him, or fill rect. Is this size 2 by 2? Or is it, what is it? Yeah, they are now really squares. The pixels are squares now. Now you can see it. Oh yeah, it's currently... Oh, you're right. We are not double buffering, but we could now that we are using the lower resolution. Shoot, I completely forgot how it's working. We have enough space for double buffering now. Do we? I don't know. Hard to miss now, yes. We might be able to do double buffering. Let me check. Where are the examples? No frame buffering, high resolution, fonts, custom resolution. Which one is? This should be double buffering. Yeah. I don't know if this is still working. This is like a super new implementation for me, at least. Let's put it here. Oh, GFX. I have a different kind of bread today for my fondue. And it's not... Okay. Now we need to swap. Draw stars. So maybe we need GFX clear, draw, and GFX show. I really can't remember how that worked, but I hope it's working like that. If I was me, I would implement it like that. Okay, that's working. Okay, now we can animate the stars. So we have draw stars. Now we can animate stars. Let's do copy paste here. Animate stars. And let's give each of the stars, so this is exclusive. Thanks for that information. Let's give each star a random speed from 1 to 10. That's like a super simple thing. And animate stars, oops. Animate stars means only that we change the coordinates. Let's begin with like super simple linear thingy. Can you even read this? I'm not sure if you're watching this on the phone. I mean, maybe scroll, yeah, zoom in a little bit. Okay, animate stars. Whoops. So we want to, let's move it minus, or yeah, minus 2 and modulo if that works. Or let's move it in the other direction. Oh, XRES. What this should do, it should move each star at its individual speed to the right and wrap around to 0 if it's exceeding the x coordinates. Oh yeah, that's like super slow. Oh wow, that's slow. I think the clear is the problem. Okay, let's make it a different way. Okay, I will show what the problem is. That's like super slow right now. That's not swoosh. Yeah, it isn't. And the problem is that the clear will perform on each pixel like this individual bit operations and whatnot. So it has to fetch the pixel from the memory to the processor, operate on that, and then write it again instead of just overwriting it all with 0. So we either do like a hardcore override of the buffer. We can prove it by changing it a little bit. So let's put the draw stars and animate stars together. Let's make it, yeah, we can do this like color black. This won't be very like correct to do right now because we will overwrite stars that are in the back, but it will be probably faster. Now we have to animate and draw in the same function. Oh yeah, the clear. Oh wait, we also don't need the double buffer. This is not what we want. Where's the double buffer? Oh, GFX show. I don't know if we need that. Oh, code. Sorry. I missed something here. Oh yeah, black isn't black. Black is white here. That will be faster. But that's no double buffering now. Ah, ow! Ah. Is it swoosh enough? It's snow. Okay, let me do more stars then. I think the codec, the video codec is going nuts currently. Let's do more stars. We want 10,000 stars. Did you miss the fondue? The fondue is still there. It's here. I have some bread, some croutons here, but I can't see anything. Oh. What's wrong? Oh, that's too big. Too much. Let's make it 4,000 then. Hello, Aaron. It's snowing. Now make it 3D. Yes, we can. Okay, so how does 3D work? Do we have still some examples here? "3D engine." Oh, code. Oh wow. We have a model, draw model and stuff. I forgot everything. I need to take a look in the library. You won't be able to. Can I zoom in? Anyone knows the key code for zooming in? I know it's not the mouse wheel. And it's not... Oh yeah, that works. Okay, great. Graphics. What do we have here? You want 3D stars. Ah, I'm getting like really dizzy from the stars. No, that's not this. Audio controller. Math. Matrix. And then we have vectors. Yeah. Wolfenstein 3D. Yes. Okay. We have to rewrite the code a little bit. Let's save this one here under Starfield. Oh, wait a second. Before I open a file selection screen, I hide it. Where is my folder? Oh yeah, that's good. Okay. Let's make it 3D Starfield. Okay, that's... I'm changing all the sizes here. Okay, what we need to do is to change this here, stars, to vector. I think it was it vector? Yeah, we have vector that has 4 floats. Then we have some transformations. I think the engine is too stiff. Where's the engine stored? Triangle tree. Yeah, that's the one. Yeah, we don't want triangle tree or anything. Mesh. We also don't want mesh. Or do we? Maybe we can put like draw vertices. Yes. Okay, we can use maybe this one. We only need to construct edges, verticals. Okay, we need to construct a mesh. That's like totally just guessing right now. I have no clue what I'm doing here. Hey, try to get a Discord channel in your server to show up on the projectors using the ESP Discord library. Okay, not now, but maybe I thought maybe interlinking the ESP so everyone could send like pixel coordinates and writing like sending UDP. No, UDP packets not, because the channel isn't open. I don't know. Obviously future idea. Okay, yes. Okay, let's take a look at the examples that we have. VGA 3D engine here. Thinker, that's yeah, that's, oh yeah, look at this. This is what we want. So this is the definition of the mesh. Let's clone it. That's normals. Vertex count, triangle count. Okay. So let's change everything here. No, this is not. Ay, where is it? Starfield. Yeah. Float. Oh. Stars. Was it like that? Yeah, float vertices or stars. We just needed to change the. Okay, we don't have any speed anymore. Let's put it in a cube of, let's say 200 minus 100, or 201. So we have plus minus 100 in each direction. Star count, yeah, that's XYZ. Then we need to construct, oh, I think my fondue is too hot. We need to construct the mesh. So model, thinker vertices. Yeah. Okay. I don't know if what the order is. Usually it wouldn't clone the vertices first. Okay. Let's check. So this is the multi-monitor GFX. And the model is vertex count is star count. And we have stars. Then we have triangle count is 0. Triangles is 0. And normals is 0. And I don't think that the engine clones it. Vertices. Oh yeah. But it doesn't clone them. That's just for the transformed vertices. Yeah. So the engine basically so the mesh only allocates an array for the transformed vertices. Yeah. That's all. The transformation happens here. And that's all. Okay, cool. That should work. Ah. Okay. Interesting now is we can remove. Okay, draw stars. I don't know. We can basically remove all this here. We don't need this anymore. Everything is handled internally. Oh, do we have a color? I don't know. Okay, let's keep the draw stars. We don't need to use it. Then let's check what the procedure is. This is video display, draw model, set cursor, print, show. Okay, we don't have draw model. Let's use this perspective here. Oh wow, yeah, let's clone it. Then we have a rotation, transform engine. I have no clue what am I. That's like 3 years ago that I did this code. Okay, we will basically do the slow clear and stuff. Video display. No, yeah, that's what we want. GFX. The projection matrix won't work because we are working on a bigger field, I think, and we need like different perspective matrices for each. Usually we will, like, if we have a cube, we need one perspective matrix for each display and draw everything six times. Okay, scaling, transform. Do we have the model? Yeah, it's called model. That's okay. And node, draw vertices. I think there is no shader. Where is the engine? Do I have an engine? Do I need an engine? What's the engine? Oh yeah, here. Yeah, the engine has all this stuff that we actually don't need. I think we need... Do we need... No, we have no triangles whatsoever. This is the buffer for the triangles. I think, I don't know if 0 works. Let's just keep it with 1. Is there setup, video display? There is no engine initialization. My triangle shader. Ooh, there is a shader. What the heck? Who implemented this? Draw vertices. Okay, vertices have only color and nothing else. That's good. Okay. Draw. Oops. Draw vertices and no shader. Yeah, let's just go for it. Doesn't work. Oh yeah, that's not working. We don't need this function anymore. We are 3D. Yeah, let's remove this as well. I think we have too many stars. That will be like a slideshow. Oh, we have mixed. Where is it? Where's the mesh? Oh yeah, here. Mixed types. No, still not. Model. Oh wow. Oi. Uh-oh. It's not compatible. Let's convert it to integer, I guess. Oops. Ah! I hate this autocomplete. It's flipping around with the... No. What's the deal? Is it short or what is it? What kind? Oh no. Let me check something. Let's make it no. VGA multi-monitor, VGA 6 multi-monitor. Okay, VGA 6 multi-monitor. What is the... I'm not sure if this still... Graphics... Okay, just for this purpose I might want to hack something. Because Martin redesigned this library and I don't know where to... If this is adapted, the 3D engine. I think it should be. But I don't see it working with specifically this method. No. No, this is not good. Is it mesh H? Yeah, it's H. Okay. Yeah, that will mess everything up. Let's see if we can... cheat. Oh wait. Graphics. Oh. This is not... That's stupid. We need GFX here, not engine. That's the problem. Hahaha. No. It should be. It's derived from graphics. Oh, can you even see it? So the multi-monitor, the GFX, is derived from graphics, but still complaining. Okay. I think we don't even need like engine, because everything is is happening outside of engine. The engine is only needed for... Okay, we have something happening here. There, there is a rotating Starfield. This works. Okay, we don't need engine. Engine is for triangles. So we can actually remove that. Do you want to see the 3D Starfield? Here, there is a cube of stars that's rotating around some axis. And I have no clue. It looks like... I can't tell if it's correct because it's redrawing so badly. Okay. Let's do it like that. We add the double buffer. Then we draw the... We make it really simple. We show it and we simply redraw it with 0 and spare the clear. Okay. It just connected. Okay. Oh no. That's not good. I need a better clear. We need to hack the clear function. Because currently it's clearing pixel by pixel and that's not what we need. We need a faster clear. Where is it? All our hacks won't work like that. We need a clear function now. Oh, just override it. Where? Multi-monitor here. What's the parameter? Oh, you can see the code, sorry. Woo! This is the show and we have some graphics. Which graphics does the multi-monitor graphics? Color mix, add RGB. Yeah, that's too slow. We just need to fill the buffers with faster because these bit operations are quite slow in the dot fast. And if we do it for like the huge display, so it has to do the complete buffer 6 times, loading into the processor and back. So we just need to override it. Or is it clear? Yeah, I know. Okay, we just need to keep the sync signals. So I would. I don't know how to access the buffer the best way. This is all your code now. So we clearly need some. Wait a second. We have a scroll function, buffer descriptor. No. Init multi. Where's the buffer defined? That should be somewhere in the buffer stuff. Buffer graphics, buffer layout. Buffer layout. Which one do we use here? This is the buffer layout that we use. W2 S8 PX. Okay, yeah. Oh wow. Okay, buffer layout is not the right. Seizure alarm. Yeah, that's the password of the buffer. It's a secure password. We were talking earlier today, Martin and I was joking that these buffer namings that completely make sense because it's 8-bit buffers with shift and word size and whatnot. They look like a secure password. I think my fondue is cold again. W8 range swapped. Okay, W range A is swapped. Age. Line 26. Clear. Oh yes. That's actually what we need. But we need to know the new color. Oh, we can basically take it like that. Can we use that? But we need the other resolution, don't we? Oh, where's our clear? I just compile it and let's go. Let's go for it. Let's see what happens. Shift static, what? I think this isn't accessible here. Memset. No, it's not memset because we have the sync signals there. Simon, yes, I am in a dungeon here. Okay, the fondue is today a little bit underwhelming. It's completely dry and the croutons are not as good as I wanted them to be. Yeah, I moved away from Darmstadt because I needed cheaper rate. Oh yeah, okay. What the... So we have value, maybe it's what? You know what? I could also simply adapt the version. What the can we take basically this version and put it in the graphics that we are using? Where's our clear? This is the buffer. Yeah, but let me. This is the back buffer. Okay, here is the wrong place. I think I will remove it here and add simply replace the one that we are actually using. This is the wrong place. I think we need to go to this one. Hack it that way now. Which way? Sorry. We are stalling. That's not good. Okay. Graphics. Graphics 8. Oh. Really? Like here in. Oh yeah, that's not. Okay, that's definitively not the right place, but it should do now. Let's try if it's compiling. No. This is terrible. Now everything is broken. Where is there? No. Let me see if I didn't break it. I have broken everything. What? Okay, there is another problem. Oh yeah, I didn't save it. Okay. Okay, this is compiling, so we can change it here. I will move it. I will just test it right now. If it's working, we will try to move it back, because that way it's completely unknown here. This is what happens. That doesn't work like that. Okay, this is too generic. We need to know the templates thingies, and we know them in multi-monitor, so we must overload it here. Let's put it here, init multi. Let's try again. This is static. Okay, this is the buffer. It's a static function. So we need this. Color to buffer, probably the same. Color to... and static color mask. Yeah, but graphics won't do it because we have a static function. We need to know the class that we are talking about. Graphics won't work. Sorry guys, it's like a little bit complicated. Okay, color to buff. Okay, color to buff is graphics. Oops. static color to buffer. Yeah, okay, I take the static then. This is missing the, I think this is missing the template parameter. Like this. No. Static color mask. This is like, oh, this worked. Graphics color mask. Okay, wait a second. Graphics are renamed, okay? Static int. I'm confused now. I need complete sentences. So static functions are wrapped. Graphics to color buff. Hello, Crafter Games. The static color mask is, where is it defined? Is the graphics color mask? Graphics color mask. Okay, that's what I wanted. So that's basically the same, like this, and color to buffer. And we need, since this is a static function, okay. That was completely random. If this works. Okay. We might be overwriting some yeah. We are violating, killing the buffer. It compiles, but it breaks everything. Martin, one question. We have like the buffer and the sync signals. Okay. Let me change something. This is not the right resolution. We have now yeah, I know the buffer is violated because we have now a complete different monitor layout. Is there somewhere the proper resolution stored or the buffer sizes? lines per field. Because we have also... Oh wow, that will be a hack. But also we have... Is the buffer continuous or do we have like split it somehow? It should be continuous. Whereas my... No. Minus... Oh no. Okay, let's just... No. Let's just try it for now. But this is only a test. If it's the problem, then I need the correct resolution. WX. Oh. Oops. Huh? Okay. That's computer graphics. Basically everything. No. Okay, no sync signal anymore. Serial monitor doesn't show anything. We lost our sync. Okay. I will do something very crude. No. Ah. The projectors turned off. We were not successful enough. Oh yeah. We got back a signal. Oh! Hacker Deluxe! Okay. Okay, we have a Starfield. Now we need some... I need some... It's like... We need to translate it. Since the Starfield is like 100 by 100 whatnot, and we have only a shift by 7, we might want to... Yeah, let's move it by 100. The camera perspective here. Oh yeah. Still too not far enough, I think. Let's move it by 200. Or let's move it far away. Okay. No, there's nothing is changing here. Matrix translation. So we have the rotation right now here. By the way, we could do some strange rotation, like where's U coming from? Where's this U coming from? Do we have a U somewhere here? That's strange. Oh, here's the U. Okay, yeah. Oops. I'm still confused how this actually, if this is properly working, because it's still too big. Oops. Yeah. Uh-oh. I simply added some more rotation to the Starfield. So around OBS is annoying. So it's rotating around all axes right now. I hate this gap. There's a gap in our stitch here. This is our stitch. So this Starfield is actually working across two projectors. Ah! Now I've broken everything. It's overlapping a little bit. Shall we add some fog? But this fog thingy just really stinks. Is this called a trigonometry lesson? Linear algebra. I can maybe explain what's happening here. So, first of all, we are just clearing the buffer, so the display buffer. Then we are preparing a perspective. So this, oh, here we have additional scaling. This is probably the problem. The matrices, we have some this is our perspective matrix, and that's basically a multiplication of different matrices. So we have a translation. We shift the complete model to the center of the screen, which is basically the center of our 3x2 array. Then we have, let me make this, whoops, make this window smaller. Then we have some scaling, and this is basically scaling by the pixel aspect ratio and 100. So basically we could do 100 here, then the Starfield gets way smaller, 100 times smaller. It should be a small box because we are far away. And this is basically the perspective. I think this is the field of view, 90 degree, and this is the near, and this is the far clipping plane. Something like that. And here is an additional transformation of the model. This is the rotation matrix, which is simply a multiplication of a rotation of this is radians. So we have u, and this is the rotation vector, which is around the x-axis. Then we have additional rotation around the y-axis and around the z-axis. And these values u, v and w are incrementing each frame we are drawing, and each of those have different increments, and they are basically static. Float means this is initialized at the start, when at the beginning of the whole program. This is initialized with 0, and then it's not overwritten every time loop is called. It's only incremented. So this is basically like a global variable, but it's only locally visible. So this is a better way of containing like global variables. Then we have, of course, the transform. This is okay. We have here the matrix M0. For me, that's basically applying the perspective. So all the scaling transformations that we do for the perspective, and also the rotation matrix. Oh, we have an additional scaling of 7. Oh, this hidden behind the. Okay, yeah. There's an additional scaling of 7. We could basically remove that because we have so many much scaling. This was basically for the example with this figurine. We don't need that here. And then the model applies the complete transformation, which is basically all matrices multiplied against each other, and that's one matrix. All vertices are temporarily transformed in with this matrix, and then they are drawn. Yeah, that's basically C++. It's inconveniently shown in this IDE, but this should work in any other IDE as well. Now we should see only a very small cube. Yeah, you can barely make it out. It's very, very small in the corner, and all the vertices. Let me change this. Okay, I changed the scaling, and now we only see a blip because it's so far away. Let's move closer then. Let's move to 150. Should be just when the complete cube is rotating. That should be just in front of us. Let's see. And should be 100 pixels across. Oh no. Oh yeah. Oh yeah, that's not good. Okay, let's make it bigger scaling. It worked better with the scaling. Yeah, let's make it 10 times bigger and move it away 300 again. It's very small. Oh, now you can see that it's a cube. It's just overlapping. Oh man. Where's my cursor here? Yeah, that's just in the center between the screens, and those are overlapping. Okay, let's amplify it even more. I do times 100 again. Okay. So this is basically okay. If there wasn't this overlapping of the screen, you can see that's our random. How many stars do we have? 4,000 stars that are basically in one cube. Trying to make a holodeck, yeah. Yeah, there is probably a gimbal lock. This is the beginning of Minority Report. Okay, let me enhance even more. Or we can do maybe not different perspectives, so maybe only not 90 degrees, but 60 degrees field of view. That should make it bigger. No, didn't change anything. I'm an imposter. If it changed, it's like more sharp cornered. Okay, let's do it again. Let's make it 1,000 times bigger. Okay, it's filling everything again. But I'm confused why we see a section over here and a section over there. Wait a second. Let me change that. We need a coverage here. Oh. Oh, I see. Those are flipped. Oh, wait. That's so wrong. Wait a second. Which one is this? This is... Oh! Oh, I got a shock. I don't know why. Okay, this one and which one is that? Yeah, these two need to be flipped. Oh yeah, that makes sense now. No, still not. I think that's completely wrong. And that should be that one here. Oops. We had the sixth one, which should be there. Oh yeah. Oh yeah. That's cool. I don't know if this is visible or not. But I connected all 6 projectors and I fixed the order. This is cool. This is cool. Focus came back. Oh, you didn't see anything. Shall we do it? Guys, shall we do it? Okay, that doesn't work as I expected. I What's up here? Oh. Okay. Okay, I don't see any rays or anything. I turn everything dark. No, I can't turn this off. Okay, this doesn't doesn't work like laser. Oh, okay. This is cool. You have to see that. I take you with me. This is basically the wrong perspective. Oh. Oh no, I'm not on battery. How do I focus this? This is looking so cool. So cool, but sorry. No, that won't focus. Let me. Oh no. Can you even see anything? Alright. Oh, it's too dark for the camera. Isn't that madness? Cool. And this is basically. We need some music. Oh wait, I have a. Maybe the other camera is better in this case. Because it has a 1.4 f-stop lens. I dropped this camera before today. It wasn't sitting properly on this. Okay, now everything is foggy. Let's take this camera. This is cool. Ah, this is so cool. I see the problem that we won't be doing much more this time. It's basically we wasted so much time. I need a there's a memory card. I need to record this. This is looking so cool. I need some evidence. Oh no, wrong card. Ah. Okay, cool. Oh, the camera is too hot. Okay. Okay, thank you for nothing. This is basically the G9 camera. I bought it for live streaming and now it's live streaming only. I can put maybe the lens on the GH5, but for now it should be cool. It's like disco. Ha! But I can't breathe with this. With this fog here. I hope the quality of the stream is nearly good enough for this to be. I just need to. Oh yeah, I see the live preview. That's cool. Okay, let me zoom in the other camera so it's more trippy. Woo! And now we need some music. Media source. Oh no. This is not what I wanted. Sorry. I wanted to put on the music. Where's my music? YouTube, templates. Video, music. Oh, that's loud, is it? I make it a little bit less loud. I can't hear it. I need to play back it so I can actually hear it. Let me play it in my media player so I can actually party with you people. Come on. Templates. Okay, I'm almost there. Okay, here we are. I'm having a party on my own! Woohoo! Ah. 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 We need a bitluni con. Yeah, but what kind of smoke? I can tell you. It's this is some kind Nebel fluid, smoke fluid, P2D, Profi. Oh yeah, that's the cool part. This is the fluid. That's Jeremy Blake, Power Up. It's in the YouTube music library. Ah. Shall we try another track? I have like a motivational playlist. Yeah, that was this soundtrack, and I have a list of my default tracks that I usually use, and we have that one. That are all motivational tracks. Aioli. Now we need some equalizer action here. Okay. Guys, I'm up to it. We can put some equalizer action, send it over UDP or whatever from the PC. So if we can code anything in 1 hour now, because that's how much time we have. If we can code it, let me focus on my face again. If we can code it in 1 hour, then we can do it. This basically, we can use zoom into the Starfield or something with the beat. But we need some pulses from the beat. I'm asking myself if we can read. We can detect beats with a microphone connected to it. Basically a digital microphone. Okay. Now I'm hooked. I need to do it. Let me check. Amplifier. Yeah, this basic Arduino sensor kits, which actually have something like that. If I can find it. Where's the sensor kit? Okay, microphone. I know I have used this before. Where's the sensor kit? Give me a minute. I just grab it from the other room, I think. If it's not here, it has to be there. And there should be a microphone in the sensor kit. Okay, it's not there. I made a project once that has used microphone. Oh yeah, here's the sensor kit. Color code. Color codes. Okay. I just. Okay, I have some microphones here. So what I just grabbed is like this Arduino sensor kit, and there we have some basic microphones that basically you can set with a potentiometer, and they give either high or low, so we can do some basic beat detection. And we have digital input pins on broken out, so we could actually, without much hassle, detect a beat and zoom in on our Starfield. Okay, I will just take one of those. Maybe we can reuse the camera of. Okay. I think this camera even has a flashlight. Yeah. Cool. Fondue cam is now used for something else. Okay, so this is what we want to use right now, and I basically need to connect it with ground and plus and analog and digital, D0 and A0. So there is some comparator here, so we can check if we see an output there. Okay, I need some jumpers. Okay, I need to turn on the lights, otherwise I will not see anything right now. Sorry for destroying the mood. That's just for science now. This huge thing in my way. Where am I jump up here? I have 3 boxes with jumper cables and I can't find any of those right now. Okay. This one is... This is only... only female keyboards. What the heck are my junkie cables? There's always something in my way here. Oh, here. Okay. Okay, so do we connect to the digital or to the analog pin? What do you think? Okay, let's do it like that. Green is plus, black is ground. And D0. Let's try it. If we get anything. Or should I check the internet first? Okay, I found it. I have a PDF. Let's okay, operating voltage is 3.3. That's okay. Oh yeah, digital signal output, analog signal output. Since we don't have any analog pins available right now, we can basically take the digital one. All okay. So let's try it. Now I need to. Do I have a flashlight here? I can use my phone for that. Oh yeah. Okay, I connected it. But now I need to adjust it maybe, because I don't see a reaction. There is an LED, but I don't see any reaction yet. I don't know what to look for. Okay. You know what? I connected to the pin 36. Let's basically change the code so we see a reaction. See a reaction if there is like or maybe on the output. Yeah, let's do basically the output. So digital read. Let's make it serial print digital read 36. 36. So that should work. No, it was the battery of my multimeter. I stepped on it and it turned on. Yeah, okay. It won't restart if I have the last port connected. Let me pull that out. Okay. That's the wrong sketch. That's the wrong sketch, but it's still working. Oh, that's the other 3D engine, and it's showing different bit fields on different projectors. That's so cool. Okay, that's not what I wanted. That's the wrong sketch. Yeah. No. That's not what we want. We want a basic Starfield, no 3D models here. Uh-oh. Come on. Something's... Okay. Boot mode. Okay, now I need an analog output. I will share it with you. Screen capture. No. Zero. Okay. It does nothing. Okay, I rotate the potentiometer. To get any other reaction here. Okay. I test if we get anything. plus. Looks like it's looks like these jumper wires aren't good. Something's off. It's turning on and off all the time. I try different jumper wires. Oh, now it's better. Does it show anything? Unfortunately, I can't. Okay, maybe I can share it. Wait a second. This so you can see what I'm doing here. So I've connected it. It's the LEDs are on, and now I try to adjust it so something changes. I don't see any reaction whatsoever. Maybe I need to turn on the oscilloscope and see if there is something happening. Okay, let's test if we can get the pin read at all. Maybe pin 36 isn't readable without any configuration. Zero, okay. 36 doesn't work. I tried 34. Do I need a special configuration for these pins? Is there something special to know? Pin mode. Yeah, I think default pin mode is read, but we can set it. What's the name of the pin mode? Is this no? Read. Input, oh yeah, sorry. You see, you don't have to be a genius to get 6 projectors running. I need to disconnect the last port. It's blocking. Eh? Oh, yeah, okay. So we have a floating pin now. Okay, so it was actually doing something. Now we set it to high. It's high, okay, cool. Okay, now it's high all the time. Oops, cable came off. It's high, now I need to find its threshold. If it's working at all, I have no clue how this thing works. Oh yeah! That doesn't work at all. Okay, we get some. Okay. It's like very sensitive. I might rather use the analog pin. Not sure if this comparator. Okay. I try with the analog pin. I'm not sure if this. Oh, okay. No. Okay, it detects a little bit of something. Yeah, I'm not sure that will work. I think the ambient noise is quite high. I hope the beat detection. I try to adjust it a little bit more. Where is it? Oh, it's not turning on at all. Okay, I tried the digital again. I'm completely blind. I don't see anything happening here. Is it still running? Okay, there's nothing happening whatsoever. I don't think this potty has so many turns. Okay, I reset it again. I think this isn't running anymore. Yeah! The communication is gone. Why? Because it's my design? Ah, clear. No. Okay, here we go. Let's start all over again. Okay, here we are. Let's see if anything happens here on the beat. No. The ambient noise is so loud. I don't think we have a chance of... I can try to get it closer to the speaker. But we have a limited cable length here. No. That's stupid. Okay, let me try the different one. We have a second one that might be better. Okay. It has a smaller capsule. Okay, this is yeah, you can probably There is the module. I turn on the music and we can see if anything happens. Nothing. Yeah, which one is the analog pin? On the ESP32. Oh, it is the 36. Oh, we can actually use it. ADC1, ADC1 0. We can connect to. We have all the 3 analog pins available. That's cool. Okay. Oh wow. Okay, thank you. Okay, they do it with analog read. No configuration needed. Okay, let's try our codes. We have actually let's see what happens. We might actually be able to do it. Guys! That's so cool. Okay. Let's see what we get on the output. Nothing. Okay, that's the digital pin. I can connect to the analog one. Analog pin! That's so stupid. That's not sensitive at all. Okay. Let me switch to plot. Yikes. There is some response. Yeah. Okay, let me... Yes. Okay, can we change stuff? Okay, we maybe try to set this to more samples here, cycles, 5, something like that. I also oh, that doesn't work. Yeah, the resolution doesn't matter if you have like the jitter of plus minus 200. How do we smoothen that out? Okay, I try the other one again. Maybe we get different results. Oh. Okay, when I directly tap it, something happens. And that's looking better. I would never be able to detect a beat there. Okay, let me play around with that. Smooth. How does smooth work? Okay. Let's change it a little bit. We have the problem right now that the microphone is red at the rate of this image here. That's not like at all what we want. We can do something else. We can create a new multi-threading task. Let's say ray tracer, or yeah, that shows how as extra task is done. Okay, so we have task handle. Let's call it analog. Handle. And this is analog task. That's basically it. Because it doesn't really help if we just pick one sample out of a vast wave data. So, okay, we don't need that. Let's move analog read over there. We should get a different rate now. Oh, Aaron, I can give you moderator rights. You should be able to post links now. Yeah, I will pin it to the other core. I'm not sure which core is which, but I will pin it to the other core. That's, yeah. We should have like, oh no, serial plotter. Oh yeah, that's what I'm talking about. Ha! Okay, guys. I mean, ladies and gentlemen, we have now the real deal here. Oh. Okay, the problem is we get a nice wave, but you see we can't output as many samples here, so I will try to smoothen it. Or let's say we just want 1 kilohertz. Should be enough. Delay 1. We just want a whoop whoop. Okay. That shouldn't interfere with the rendering task anymore. I don't know how real time this is, this line. Should we multiply it with a sine wave? The range also seems very limited, yeah. I know we have a sinus table somewhere. Change the analog read. Okay, let me check what you posted there. Where do I see it? Value readings. Okay, yeah, mean readings. Oh. Okay. So basically it's the same as no. Oh, this is the function. Okay. Yeah, but then it just this is like we can do something similar. That's okay. It's averaging basically. Yeah, we can do this. Let's take 4 samples. Oops. Oh, delay micros? What's... Yeah, okay, it's just averaging over... Let's say we want to do this, and then... I think that we have like single outliers. Okay, we still get some, but the amplitude is so low. It's so low. The amplitude. Is there a DFT built in somewhere? No, it isn't. No, we we can just use like. Okay, yeah, it's losing sync again. We are too fast here. Maybe we take 10 samples. Hello, music. Okay, we could do a DFT. Yeah, that's yeah, that's basically what I would do for um, the mean value. So we have like no. We do some double smoothing. Always write this F, otherwise it's calculating double precision and we don't need double. It's way slower. Single precision is in the processor, double precision has to be emulated. Where's the plotter? I don't see the plotter. Oh. Okay, I turn on the music. Yeah, that's like 8 plus minus 8. How do we do the beat detection now? I would do a DFT. Okay, anything above. Okay, now we just need to take the amplitude of that. And we will use the amplitude as the zoom of the Starfield, okay? So the amplitude is wait for it. Ah. No. Let's do it like this. Float. But that's not what we want. That's not yet what we want. Hello, Sion. I would be done with DFT a long time ago if you would let me. Oh, what is that? That is horrible. Okay. This is what we want. So we have an attenuation on the maximum amplitude, and we simply take the maximum of the current sample. Okay, this obviously needs more smoothing. That's not enough. Okay. Oh, what did I do? No, that's wrong. Sorry. I need the attenuation here. I'm very confused. No. No, that's not what I want. I'm using like an Arduino sensor kit board, putting and using the analog pin. It doesn't need to be perfect. We don't want to record anything, but we want simply to detect the beat. Currently our state is that okay, I don't have all projectors on right now, but 6 are working side by side with a Starfield, and we are losing the sync only because we are simply spamming the serial ports right now for debugging purposes, of course. No FFT right now. If you give me a simple FFT implementation, maybe there is one in the ESP library, I will take it. Otherwise, I would simply do like a DFT or something. No FFT, DFT. Okay, okay, guys. What frequency do you want? What frequency do you want? I create a sine lookup table, or we can, okay, we can do it like super slow, but this probably won't work properly for this one here. And we don't need all this smoothing and all this stuff. We can simply take the noisy input and use a DFT on that. So we take like analog read and multiply it by sine micros times one. What frequency do we want? (100 Hz) times 2 times pi. And okay, we can do delay microseconds here. Say 10. What's our integration samples? 10 samples. Integration interval 10 microseconds. Let's do 100 samples. That's 1 millisecond. That's not enough. We want 200, 1000 samples. So we get analog read. Yeah, that's not possible to have like 10 microseconds. Now the floats. Oh no, we have amp. Okay, let's use 0. Let's see what happens. I probably have a mistake there. Yeah, color code. Oh, there's something wrong. And oh yeah, it's microseconds probably. That's a crude method here. Oh yeah, here. Let's improve the speed a little bit. But something's off here. So this is our integration. We calculate the phase of the sine wave in the frequency we want, but micros is probably not the best. We want 100 Hertz. Let's try millis. I don't know if micros is good enough. It's probably not precise enough. Oh, you can't see it, sorry. That's what's happening. I have no clue what... I don't know what this thing is calculating. You just make amp bigger and bigger. Yeah, but I reset it every 1000 samples here. So this is like our integration frame. Oh wait. Yeah, we need to... Do we need to divide it by 1000? No. It should cancel out. We have like positive and negative values. Okay, I will try color chords C. Let's see if that works. No, we don't need to subtract the start time because we want the actual phase of sine. It needs to be to continue in the next loop. Otherwise, it will be choppy. Usually, that's like this DFT works, but that's like just I didn't do it for ages. Okay, so where were we here? Oh wow, DFT and DFTC. So these are the bins, these are the frequencies, count of bins, data buffer, place in data buffer, size of data buffer, and float Q. What is Q? Oh, you can't read. Okay, sorry. Do DFT quick. Float speed up. Oh wow. Okay. That's too much for one session right now. Let's get back to our crude beat detection. Oh wait. The analog read, we need to subtract the mean value. Because this is not normalized. It's like we have a bias, a DC bias on that. So we need to minus mean. That might be the problem. And we need to calculate the mean value, which is... Where's the mean? Mean, oh yeah, that's sample. That might help. Oh wait. The mean is the coarse. Okay, we need to wait for this to clear. It might be something not equal 0. I would use rather this. Oh! Ha! This is our DFT working at 100 Hertz. Wait a second. No, it should be positive. Okay. ABS, no. ABS would be. Oh, this is evil. No, no. Oh! No. I don't like it. Yeah, but basically it's the same as doing whatever. We can try the micros again. Maybe it's better. It's a poor man's DFT. Also that basically doesn't sync up with the music at all, in my opinion. Then rather let's do the old version. Oops, we lost our mean. No, we need a running average here. And then let's do it. Okay. It's not a running average. Okay, we could do a running average, but I don't want like an array or something. Let's do a basic average, whatever. For... Oh, I'm tired. Let's try like this, and then we can do the running average. Yeah, that doesn't matter. We don't need to calculate anything here. Poor man's average. Oh, what was this spike? Oh, we are almost there. Oh, this noise. Okay. We have values when the music is running around 100. Okay. Instead of outputting amp, we are putting the amp outside here. Float is 32 bits, so we don't need mutex or whatever. We will basically take the amp right now and put it on the Starfield here. This is like... Do we scale it or do we zoom in? We need 300 minus amp. That's all. Then we are done. This will be jittery, but it's jittery, it's black and white, but it's mine. Oh no. Oh no, we lose sync. Fuck. We need more delays. Unfortunately, this is bad. Okay, microseconds. We need a basic delay with 1 millisecond, otherwise it won't work. Fuck. Okay. Let's test it now. I zoom out. I don't know if the music will do anything. One projector is not connected right now. Let's try music first. No. I don't think it works. It's like really random right now. But we also changed something. We need to plot again. Otherwise we don't know what's actually happening there. And we are really delayed. We are 10 times slower now. So I'm actually not sure if it's viable at all right now. I need to disconnect the last one again. Uh-oh. Ah. Warp speed effect. Google wanted me to censor your message. What? Okay, this is our... No, this is too slow now. Okay. No averaging here anymore. We have basically to take what we get. Sorry guys, this is... Johnny, I never saw this hex code before. Okay, let's test music with the new and better. That feels like completely out of sync. How do I fix that? Running average. Okay, okay. Last thing that we do. Hundreds. Oh, sorry. Okay, so we have this amplitude here, and we don't want this loop here too slow, but we want the amp to be we need the sample. Let's say sample equals, okay, sample minus mean value. Then we want the running maximum. So we take the absolute value of the sample, put it in CA. Let's make it 128. CA like that. Then we want amp maximum no, this is now the sum of all absolute values. There is no maximum. Okay. Let's see what this gives. We can increase this again to be, because it's too fast now. Okay. Okay, what's happening here, what I wanted to do is I store the last 128 values, and I have this amp, I subtract the last value that's basically going away, overwriting it. This is the current position, current value, with the absolute value of the sample, and then I'm increasing the pointer so it loops around all the time, and writing, oh wait, no. Yeah, no, that's right. No, that's not right. This is right. Okay. Thankfully, I just need to add the new sample. So I'm subtracting the one that's going away and adding the one that's coming. Yeah, that's better. Okay. That's like a running average or something. That's That's stupid. Let's do it like that. It's too much delay. It's 100 milliseconds delay, or let's say on average 50 milliseconds. Okay, let's do it like what is acceptable. Let's try 32, but that's really not much. We need this delay here, otherwise we get problems with, or we can use delay 0. This is, yeah, 64. I don't know if this is better. I don't know how quick we read the values now. If we lose the sync or not. Yeah, we lose the sync. I also don't like the ABS, but I don't know what to do about it. Okay, let's do not inverted. It doesn't matter if we get a negative average or something. But no. That basically... Well, what's the best method to calculate the amplitude? No. We get like, it averages out. If we sum up 100 values or 1000 values, it will average on 0. So that's not what we want. We want the amplitude. How Calculate. Ah, no, that's of a specific way. Yeah. It sums up to 0. Hilbert transformation. Or we do something really stupid. Okay, okay. Yeah, the envelope, but how do I get the envelope? Okay. That's not what I wanted. Okay, we need the, no, we need sample ABS, sample, we don't need that crap here, we don't need that crap here, let's take the bare sample. Ignore that here, everything. Why is this so choppy? Something's off here. Okay. We don't need the mean value. Let's ignore that. Because we are looking, we only want the, it doesn't matter if we get like the negative or what not. Let's just concentrate on the sample itself. And we have absolute anyways. That's the... Yeah. Oh, shit. Sorry. Again. Okay, maybe we need the mean value. but we want to divide maybe this by 64 anyways. Yeah, we can divide. Camera gone. No! Why is my camera gone? Okay, my face camera is gone and I don't know why. I doing a max, a rolling max. That's like, I could take mean right now. Okay, that's. Oh wait. In case I did something wrong, but this is basically what we had before. Oops. I don't know why my camera turned off. My face camera died. I don't know why. Ah, here we go. Wait a second. Here, this again. Let's remove this sample. Oops. Now that's the basic. Yes. Yes, I am. I don't know if this is like, maybe we should make it slower. Oh, we are long into the stream right now. Let's put a constant DC offset on top. Yeah, it's just noise. Let's display the mean. Yeah. That's basically what we get. It's the average value, but then we can only read one sample per millisecond. Otherwise it will start bugging out. I think that's the problem. We have like only a sample rate of 1 kilohertz. I don't know what we try to do there. Oh no, it's not right. I have no idea. Yeah, I'm introducing new bugs. That was obviously a bad idea. My cheese is cold. We are basically done. What is this? There's like plenty of noise. Okay. This is useless. We can still use color code via UDP instead of this doesn't work. Delete it, yes. analog stuff on here. Let's try sample analog stuff on the ESP32 is useless. I basically end the stream and then delete the last 10 hours. But I can see a change there. How do I take this and make something useful out of it? I should be able to calculate some kind of volatility on that input. Look, you can see you can see my speech. RC filter, what? Yeah, but if I do a RC filter, it will average to 0. Oh, I can turn this off? How? No, I can't turn it off, sorry. Okay, let me take another music example. No. Okay. This doesn't work. Oh yeah. Obviously, my voice works better than the music. In the meantime, I hooked up color code to my WLED strip and it goes crazy. Yeah. Wow. Das ist gut. Nicolas. Okay, capacitor. You want a capacitor. Not a huge capacitor. We need a small capacitor here. We can take... Where do we have capacitors? Nano. Let's break something. Okay, that doesn't help. It was 10 nanofarads. Let's do 10 microfarads. Or let's say no. Okay, 10 microfarads. Usually it shouldn't be very high. Doesn't help either. No. It doesn't help. The problem is within the microcontroller. What we are doing is basically very noisy on the board. Three 3,000 farad. No, okay. Okay. I can obviously see my voice in this graph. Tell me, how do I get my voice out of this graph? Inductor line. Yeah, but little inductor inline. Chris, I trust you because you are such a genius. Okay, inductor inline. Okay. What size do you want? I have 1,000,000 inductors. I have all the inductors here. I have inductors where other people don't have inductors. I have inductors that are so huge. Nobody ever has seen such inductors before. I take this inductor now in line. That's some kind of inductor here. I take this inductor okay, how do I do this? This is the inductor. Uh-oh. This is with the inductor. Inductor no good. Okay, this is back to normal without inductor. It was an inductor with a ferrite even. Small inductor. Okay. I take now the smallest inductor ever. Like this one. I don't know if you can see it. It has like 3 windings. No. Okay, I take something like an air coil here. This air coil should be all right. Something like that. Oh. Let's take it. Still. What? No. No. Doesn't help. It's only confusing. Okay. This is not, this won't work like in mid-air, obviously. But I see the signal. I see it. I can see my voice. Okay. I have a different idea. How about we take just 3? Not many, just 3. No, it's powered from the PC. Otherwise, we wouldn't be... Oh! Okay. No. Oh, wait. No, that's not right. Is it, though? No, 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 no. Okay. No. We need that are like completely unrelated. We need to do it like this. No. No, that should be that. Madness VGA. Yeah, basically it's complete madness. Oh wait, no. What is happening here? This. Yeah, I just take some samples. Some consecutive samples, but that doesn't work at all. It's like all over the place. I see something there, but it's like really bad. Okay. Oh yeah, butter. Butter should do us a favor here. Okay. I see a lot like the volatility, the average volatility here. We need to calculate that. Okay, volatility is squared, but ABS is also okay. That's like the deviation. Standard. I can't see anything anymore here. Nah, that's basically what we got before. We get those jumps exactly where... Oh, wait a second! Doesn't look very bad though. But every time we get like this spike... Oh, wait a second. I have an idea. We need the delay only every 10th sample or something. Ah! Let's take 10 samples. This way we can say average 10 samples even though yeah, something like that. The code is really not readable anymore. Why I am not doing a sliding window after sampling? What do you mean? Yeah, we need to group. Okay, this is basically, this is doing what we want. The auto scaling is a little bit confusing right now. Let me run the music. Maybe it's actually what we want already. Okay, we have some kind of jitter that we need to smoothen out. Okay, Chris, this is a ring buffer, 20 values. Okay, we can do 30 or whatever, 32 values. And this is basically, okay, the 32 looks even better and it seems to react faster. It's still jittery and a low, oh yeah, it's like 70. The noise is quite high. We have like a noise of 50. Okay, let's turn on the music. Okay, this music is obviously not good. How do I turn this off? Oh. And wait, what? Sorry, it's too loud. Okay, this amp doesn't doesn't work. We are just guessing. I'm just guessing at this moment. We had a better output already. Let's get another example, maybe. Let's just clip it away. Yeah, I could. Okay, we have some kind of beat detection here. Even though it's random. Yeah, I need to find something with a beat that I can play. Okay. It's like delayed. Oh! Yeah, it's delayed. It's delayed, okay. Let's do it more reactive. And we should also okay, guys, I give up. Next time, UDP. Next time. I put another music on. Ah! This. I give up. Ah! I connect the last one. Okay. This is the outro. Let's do Thank you guys for joining the stream, and I see you next time. Bye.
Ha ha ha!